Photoaging is the gradual and irreversible deterioration of collagen, elastin, and other fibers that give structure to the skin and keep it smooth, caused by age and accelerated by solar radiation. Extrinsic aging or photoaging is determined by chronic exposure to ultraviolet radiation, both A and B, which is cumulative and irreversible. It is manifested by functional, molecular, and structural modification of the skin in exposed areas such as the face, neck, forearms, back to the hands and neckline. The degree of photoaging depends on genetic factors, skin phototype, and the repair capacity of DNA mechanism. In photoaging, ultraviolet A and ultraviolet B radiation activate immunosuppressive mechanisms through certain cytokines, thus contributing to photodamage and eventually to photocarcinogenesis. Ultraviolet B rays are considered to be responsible for sunburn, skin change, and carcinogenesis, and ultraviolet A rays enhance the effects of ultraviolet B rays in the deepest layers of the skin, where the main change of photoaging occur due to cumulative effects.
The mechanism by which ultraviolet radiation initiates molecular change in the skin is through the generation of reactive oxygen species that act directly with the lipids of the cell membrane. In addition, ROS cause the oxidation of other cellular constituents such as a protein and DNA. Ultraviolet B rays and, to a lesser extent, ultraviolet E rays directly damage DNA and induce genetic components such as pyrimidine dimers. Ultraviolet E rays damage more indirectly through ROS, but also contribute to direct damage. With cumulative damage, the cell degrades its antioxidant capacity, which exacerbates ROS-mediated damage engine. Ultraviolet radiation triggers molecular change responsible for damage to the dermal connective tissues. It causes the activation of growth factor receptors, pro-inflammatory cytokines IL-1, TNF-A, IL-6, IL-8, and adhesion molecules of the surface of keratinocytes and fibroblasts. Some mechanisms that lead to photoaging are membrane alteration, telomeres and telomerases, protein oxidation, and mitochondrial damage.
The global scale measures severity of photoaging and wrinkles. According to this scale, there are 4 types of photoaging. The first one is called mild. It appears in people between 28 to 35 years. This type doesn't show wrinkles, and another characteristic that this type presents is that the skin presents early photoaging, which is mild pigment changes, no keratosis, minimal wrinkles, and minimal or no makeup at all. Second type on this scale is called moderate. It appears in people between 35 to 50 years old. It presents wrinkles in motion, and the skin presents early to moderate photoaging, which is early brown spots visible, keratosis palpable but not visible. Also, some parallel smile lines begin to appear, and is recommendable to wear some foundation. The third type on this scale is called advanced. It appears in people between 50 to 65 years old. It shows wrinkles at rest, and the skin shows advanced photoaging, which is obvious discoloration, visible capillaries, visible keratosis, and is recommendable to wear heavier foundation. Finally, the fourth type on this scale is called severe. It appears in people from 60 years old and up. It shows only wrinkles, and the skin shows severe photoaging, which is yellow and gray skin color, prior skin malignancies, wrinkles throughout, and non-normal skin. This type of photoaging doesn't allow the person to wear any makeup at all because it cracks and doesn't look.
Clinical signs of photodamage. Wrinkles. Photodamage produces deep and thin wrinkles. Facial expression lines are very marked, dynamic wrinkles, and the laxity of the tissue leads to the formation of wrinkles without seeing gravity wrinkles. Vascular changes: the small vessels of the upper dermis lose their supporting network. Vascular ectasia, wide atrophy of the walls occurs, persistent diffuse erythema, and the presence of numerous telangiectasias and sometimes legs or civettes poikiloderma are common. Atrophy of thinning, transparency, laxity, cirrhosis manifests clinically as thinning skin with an easily visible venous network. Laxity, alteration of the elastic fibers. The skin does not return to its place or begin stretched, dry, right, flake, and sometimes cracked skin. Pigmentary dyschromias, melanocytic, epithelitis, develop after exposure to UV radiation, especially in the skin white photopy 1 and 2. Actin lentigens. They develop in the exposed areas and are considered to be directly related to UVA radiation. Non-melanocytic, they are generally related to vascular change. Non-pigmentary dyschromias, elastoidosis. Sebaceous hyperplasia solar common in stellate scars. Sebaceous hyperplasia affects the face, predominantly the forehead. Keratosis are associated with the risk of squamous cell carcinoma. Neoplasms risk factors are for skin difficulty in tanning, advanced age, AC burnings, and burns before the age of 20.
Photoaging and its alteration in its layer. Epidermis. Thickened acanthosis. Atypical irregularity in cell size, loss of polarity. Increase of melanocytes. Decrease of Langerhans cells. Late teens, early acanthic keratosis. Hutchinson's malignant leukolysis. Second, dermis. Increased elastin elastosis. Increased glycosaminoglycans. Abundant and partially monomolecular cells. Decreased collagen. And finally, prevention and treatment. Vitamin C. Stimulates collagen biosynthesis, decreases UV alteration and bipyrotrophy. Vitamin E protects lipids and protein structure from oxidation, prevents lipid peroxidation. In the epidermis, decrease UV-induced glucophario depletion, increase superoxide diminished level, fluoradenine, gluteins, free radicals, and removal of damaged macromolecules.